E, E, C. Good. Now cover the other eye. D, E, F, P, O, T, E, C. Very good. You're okay. You have 20/20 vision in each eye. Now take this paper home to your parents.
The Snellen chart. We've all seen it, been tested with it, and if we did all right, everyone thought our vision was fine. Perhaps it was. Hi, I'm George Page, host of the public television series Nature and Other Science Programs. One thing I've learned from my work is that nothing as complex as human vision can be thoroughly explained or tested so simply. This chart, for example, tests only for visual sharpness at a distance of 20 feet. But what about clarity at reading and writing distance? Not to mention convergence, saccadic eye movements, and visual integration. I'll talk more about those later. The point is, there's more to sight than sharpness, and more to vision than sight. Vision is a complex interaction between the eyes, the brain, and the body. So complex that 40% of all children have some form of vision problem that can seriously affect classroom performance. What may at first glance seem to be a question of IQ or motivation may instead be a vision problem. Let's briefly explore the components of human sight and discover how these components interact to create vision. Vision can be broken down into three parts: the gathering of visual information by the eyes, the processing of that information by the brain, and the integrating of that information with the brain and the body. This is a very complex series of events, which ideally takes place in a fraction of a second. Let's take a closer look at the gathering, processing, and integrating of visual information. In visual gathering, the first thing you need is physically healthy eyes. Any disease of the eyes, such as cataracts or a detached retina, will interfere with the gathering of visual information. Something as subtle as a color deficiency can also distort incoming visual information. Next, the optics of the eye are examined. Ideally, light rays passing through the eye are focused here on the retina. If the eye's optics are too strong, the light rays are focused in front of the retina. This is called myopia, or nearsightedness. In other words, you can see close up, but you have trouble at a distance. If the eye's optics are too weak, the light rays are focused behind the retina. This is farsightedness. Astigmatism occurs when there are two different powers in the eye. Glasses or contact lenses compensate for these deficiencies. The light is now coming into the eye free of disease. The optical problems have been resolved. Now, both eyes must point in the proper direction. This is called binocularity. This delicate balance of alignment of the eyes is maintained by the brain's control of 6 muscles surrounding each eye. The correct alignment of the two eyes produces a fused picture. The eyes must also maintain alignment as we look closer and farther away. As we look closer, the eyes converge or turn in. As we look farther away, the eyes diverge or turn out slightly. If the eyes are not properly aligned, then two distinctly different pictures are sent to the brain. When the brain encounters this confusion, it will usually choose to ignore the picture from one eye and simply turn it off. This is called suppression. A misalignment of the eyes not corrected over time can develop into amblyopia, or lazy eye. A severe misalignment of the eyes, called strabismus, would cause a child to look wall-eyed or cross-eyed. Strabismus receives a lot of attention because it's very obvious. Small misalignments are not so obvious and probably wouldn't be detected by parents or teachers. But it's the small misalignments that can cause serious problems in the classroom. Symptoms may include rubbing the eyes, squinting, headaches, and unconsciously blocking one eye while reading. The picture now coming to the brain from both eyes is fused, but not necessarily clear. To clear the picture, we must use our focusing system. Inside the eye, behind the iris, is a small transparent structure called the crystalline lens, which is responsible for the changing of focus. First, the amount of focusing must be normal for age. A child, for example, can place a book on the tip of his nose and read the words clearly. A 40-year-old is lucky to hold a book at his arm's length and barely make the words clear. Secondly, the crystalline lens must be able to change focus quickly and accurately, such as when looking from reading distance to a chalkboard and then back again. Finally, the crystalline lens must be able to sustain any level of focus as long as needed without fatigue. This enables us to see the words in a book clearly without having them blur in and out of focus. Possible symptoms of a child with a focusing problem might be squinting, frequent headaches, rubbing the eyes, and possibly even the avoidance of reading tasks. Not only must the eyes properly align on the same point and focus, but they also must move together as a team. The eye movements we use in reading are called saccades. These eye movements enable our eyes to move properly across each line of the page and accurately jump from the end of one line to the beginning of the next without losing our place. A child with an eye movement problem might frequently get lost while reading, skip lines or words, or could often use his finger or a ruler as a reading guide. Now we move from the gathering of visual information by the eyes to its processing in the brain, where sight becomes vision. After visual information has been gathered, it begins its journey along the fibers of the optic nerve, 20% of them to areas in the brain controlling balance and movement, and 80% to an area in the back of the brain called the primary visual cortex. It's here, at the level of the visual cortex, that the visual information is broken down into its parts, sorted, and then reassembled. This process is called visual analysis. A child with a visual analysis problem has trouble understanding the relative importance of different things he sees. Try to read sentences without spacing or punctuation, and you'll begin to understand the world of a child with a severe visual analysis problem. Another common symptom is letter reversal. A child sees the letter P but writes Q, sees B but writes D. Obviously, this can be very frustrating. It's not enough just to be able to accurately break visual information into its parts and put it back together again. We must also compare what we see to things we've seen before. Otherwise, we'd have to figure out what we're looking at all over again every time we see it. A child with a visual memory problem might have trouble with spelling words, sight words, or flashcards. After the visual information has been gathered and processed, it must be integrated with other parts of the brain and the body. Visual motor integration, or eye-hand coordination, is important when learning to write. A child can find a visual integration problem very frustrating in the classroom. He may know the answer, but has a difficult time writing it down. He or she might exhibit sloppy handwriting or very slow handwriting. Visualization is the ability to manipulate images we see with our mind's eye. It allows us to see in the mind how a project will look before it's finished. A child having trouble with visualization might start to write or draw something much too large at the beginning of a piece of paper, and then be forced to cram the rest of the assignment into what little space is left. You've heard the expression, the whole is greater than the sum of its parts. Well, that's certainly true of human vision. The eyes, the brain, and the body all working together, gathering, processing, and integrating visual information. A complex interweaving of information, all in the blink of an eye. Just because the eyes are working properly, you can't take for granted that the entire visual system is functioning properly. Each area can and should be tested in order to determine its ability to perform as a part of the whole visual system. It's important because problems in any one area can adversely affect classroom performance. For example, many people assume that if you can't write the answer, you don't know the answer. But we've seen that a child with a visual motor integration problem may be able to say the answer, but not write it. Why not? Because the eyes, brain, and hands are not working together as a team. A child may be labeled as having a short attention span, when actually he may be unable to focus or align his eyes at near point, reading distance, for more than a few seconds at a time. Reading for that child is a frustrating ordeal. A child with poor saccadic eye movement skills can't naturally find and keep his place in reading. If he concentrates very hard on keeping his place, he can do it, but then he doesn't retain what he reads. We've talked about other symptoms of visual problems: headaches, hiding one eye with a hand, avoidance of near work such as reading and writing, and academic performance below expected levels. Some symptoms are obvious, while many others require a professional to detect. And like every abnormality, the sooner a problem is detected, the easier it is to correct. That's why parents are encouraged to have a diagnostic evaluation performed on their child's visual system by an optometrist. The doctor of optometry is the professional trained in the diagnosis and treatment of difficulties in the gathering, processing, and integration of visual information. In other words, optometry is the profession that relates vision to performance. The diagnostic evaluation can be performed quickly, and should a problem be found, your optometrist can offer a special therapy program for your child. This therapy takes place in the optometrist's office with exercises for the child to take home. It's designed to teach the eyes, the brain, and the body new ways to work together. If you have any reason to believe your child might have any of the vision problems we've discussed, as 40% of all children do, have your optometrist test them. It might be the best investment you can make in your child's future.